Hi everyone, and welcome to the last week of our Cairo Bootcamp 5. Today is the week 5 of session 1, and we'll have Black Adam, quite an interesting name. He will go through Cairo security, the best practices, and everything you need to know about Cairo security, like I said. But before we dive straight into it, I would let Black Adam introduce himself and also talk about the agenda we will have for today. So, Black Adam, you can take the mic right now.
Okay, hi everyone. My name is Black Adam. I'm a security researcher, and this is my Twitter username. So today I'll be taking you guys on Cairo and Starknet overview, the security fundamentals around Cairo, common vulnerabilities, best practice and pattern, and how to get your project audited right. And on this past month, you guys have been working on Cairo and get started with Cairo and everything related to how Cairo works. Um, One thing about the way let me just move on. Let me tell you about the way Cairo is different from other languages. When we talk about blockchain, we have different languages that you can use across different blockchains. But Starknet is unique in its own way, and Cairo is unique in its own way. Uh, I'll just do a brief rundown of what this is all about because I know you guys must have done talk about this already, but just to create a mental model of what I'm going to talk about today, I just need to like brush through this and why we need to have this understanding. So Starknet is the ZK rollup layer on two on Ethereum. And why do we have Starknet? Why do you think we have Starknet? Starknet works as a layer two in the sense that because of the issues with layer one, which is very expensive to run transactions on layer one. This brings the idea of having layer twos, and we have different types of layer two. We have Starknet, we have Base, we have Lisk. With Starknet is unique because it uses Zeki. Zeki technology makes it very fast to run transactions without you using high computational power compared to other layer two. And then it uses Stax Pro for scalability as well. And the contracts are written in Cairo. So Cairo is a programming language. Uh, it's Rust like, okay, yeah. So and then this is what is Cairo. Cairo is a Turing complete machine. And what do you mean by Turing complete machine? Is a machine that can run all computation. So and it's a high level. It's not a high level level language. It's a low level language. And what this means by a language being a level language is all data types are strictly you have to declare data types of each variables that you're working with. Unlike JavaScript, whereby with JavaScript you can just write your var, your let, your const, and it works. It doesn't work like that with low level language. You have to data types. If you're storing a string, you have to declare that variable as a string. If you're working with not integers, you have to declare variable as integers. So that's the level language to you. And also, Cairo is a provable language in the sense that it's so close to zero knowledge and it's very efficient to write codes with. So Cairo program set of instructions written in Cairo programming language. All right, I will just keep through all this. All right, so we have Cairo program, we have Stacknet contract. So Cairo programs are just programs that do not have access to the state in the sense that when we talk about contract, we talk about having access to the state, to the chain, to the L1 environment or L2 environment, whichever the chain is. With Cairo programs, it's just a program that is right to just work the way it's going to work without thinking about having access to maybe block the timestamp or any of those things. You just want to run your programs to do maybe addition, subtraction, any of these things without worrying about having data from the chain, using data on the chain. So, and it uses the Cairo runner to run. And then we have the Stacknet a contract, which deals with having access to the state of the blockchain. And then you can modify the variable in the state. You can read from the state. You can modify what you have on the state. And then you can also interact with the underlying head one, which is the Ethereum now. And I think we have a protocol that bridges that works with BTC now. So we can even have programs that make calls to BTC. So this is an example of a Cairo program. It has the executable. Sorry, a minute. So it has this executable is what makes it run. So when you run your Cairo runner, it looks for the executable micro and calls the function inside whatever inside the executable macro. All right. So to the main topic why we are here today, Cairo security fundamentals. All right. So first thing first, Cairo is not solidity. I know I know some people have background in solidity already, and when they want to start writing Cairo, they bring the same approach of idea they have about Cairo to about solidity to Cairo. It doesn't work like that. Cairo uses state in the sense that you have a struct, uses storage rather. You have a struct that handles your storage, whereby you declare all your storage, your int value, your mappings, your state variables is inside that struct called storage with the macro storage. You know, unlike Solidity whereby you have everything your state variable, you can write it at the top of your code. You can declare your variables there. With Cairo, it doesn't work that way. And also, with Cairo, you don't use there is no the native token operation on Cairo is an ERC20. Unlike Solidity where you have message.value where you want to send the native token on Starknet behaves like an ERC20. So you're basically working with ERC20 when you're dealing with the native token on Starknet as well. So Carry uses FET252 instead of UNT5C. So the default the default data types for variables in Cairo is FET252. And then you have to declare explicitly the storage and memory handling. I've talked about that. And one other thing is strongly typing is not equals to safe logic. And what I mean by that is when we're talking, people think when a language is strongly typed, it is safe from bugs, it is safe from vulnerability. That's not true. Although in some scenario, when a language is strongly typed, it saves it from other it makes it unique in the sense that it's safe from other types of bugs, right? But it doesn't mean you are totally safe from bugs. So that's it. In fact, when you work with strongly typed language, you start discovering other kind of bugs that you are not used to with other languages that are not strongly typed. You can see something like buffer overflow, all those things. When you're working with loosely typed language, you don't get to see those kind of bugs. But when you're working with strongly typed language, you start seeing languages that bugs that are peculiar to the architecture of that machine, right? So common vulnerability. So we have logic on stating inconsistencies, integers and faith pitfalls, storage misuse, access control failure, unbounded loop transit. So these are just like some vulnerabilities that I when I work with Cairo that I've discovered and I just allied them. There are more than this, right? But I just allied some of these here. Although reentrance, this last one that we have here, reentrance, um, by the architecture design of Starknet, there is no reentrance in the sense that you don't have message value, you don't have a contract does not have a fallback or a receive functions. And when you work with Solidity, you have a fallback or receive functions that can get triggered anytime native asset is sent to that contract. But with Cairo, you don't have that. So reentrance is kind of before reentrance is kind of done in a unique way. So, and now we talked about, and I'll show an example of how reentrance is done on Starknet. Okay, so I want this class to be interactive. So I'll be showing you my screen, and I will ask you what do you think is wrong with this particular function or this particular code snippet, and I would like to have your answer. Then we will debate. Then we'll talk about uh what do you think is wrong? So I don't know if you like to drop your answer in the comment section or you like to raise your hands up. Looking at this function that you're looking at this function, total deposit, what do you think is wrong with this function? Anybody can just do that. Hello, hello. I still on the call.
Hi.
All right. So I'm saying looking at this function, this code snippet here, what do you think is wrong with this function here? Okay, so I will just go straight. Looking at this function now is a deposit function that's taking an amount in and it's doing self total deposit. That's right. That means it's changing the storage here and it's changing total deposit storage here. But there's an issue here. It doesn't account for the amounts that I have deposited before. So because most times when we write as a developer, when we write code, we are after our code working, right? Just I want to do 2 plus 2. If you give me 4 and give me 4 and I'm okay with it. But there's something called attacker mindset that me as a security researcher, I'm not looking at the code base from a developer's perspective. I'm looking at the way of how can I break your code. So you in your implementation has 2 plus 2 equals to 4. And then I can look for how can I prevent your 2 plus 2 to give me 4? Or what other factors can I add together that will give me 4? You as a developer, you after this thing should work this way, right? And it works. But I'm looking at, oh, what can I do that will make this thing works in a different way entirely? So security consciousness may not be your top priority while writing as a developer. I just want to write. Maybe later when you're done writing code, you can start going through each line after each other just to locate if there's anything wrong with it. But while writing, the first thing is just to write the code to make it work. Then you start looking at the security part of it. So looking at this function now, yeah, deposit works. I was able to deposit, but there's an issue with this deposit, and which is the fact that this it did not account to the total deposit that this contract have before assigning it. So there's an overwriting of data here. So let's say I've deposit to this. Let's say this total deposit on this contract is probably 200 USDC or something, 200 ETH or 200 start token, and then I'm depositing another 100 now. This deposit will try is going to overwrite whatever we have here, and it's going to be 100. This is meant to increment. You should have 200 plus 100, making 300. But at this point, with this code snippet we have, there is overwriting, and we only have 100. And you can see this is the correct implementation of it. You have to read first what is inside this storage, and then we add to it. All right. Okay. So, and here is another code snippet again. Can anybody tell me what is wrong with this code snippet? You can omit and just say something. Just say something, whatever you think is wrong. That I can tell if you are right or wrong. Okay. I think I will just say the answer for this one as well. So, um, if, the issue here is the developer that wrote this code thinks probably uh, this secret password here is safe that people cannot have access to it. And the way this code works is the owner set a secret key here, and whoever wants to withdraw the balance of this contract must pass in the secret to be able to unlock it. And there's an assert uh there is a check here that checks if the secret you are passing in is the same secret that is saved in the storage here. So if it is the same secret, it transfer all the vote balance here to the user, right? And then set this to 0. But this is it. The issue here is everything on the blockchain is transparent. So people can see whatever is showing the transparent, irrespective of if you have a preserved functions that or a secret that you save and you are using a password to unlock it. It doesn't work that way. So I can go through the blockchain and look at the state of the blockchain and look at whatever I saved in this particular struct, and I can get the secret password, and I can just come here and pass it in and then get the funds out of here. So this secret is not secret. It's open for everybody to see. All right. So yeah, basically everything I talked about here, this is a summary here. It's storage misuse, overwriting critical state, mixing up mappings and variables, incorrect storage keys, right? It's, this is the first one that we talked about, the writing critical state, instead of knowing what was the total deposit before adding another one to it, instead of writing. All right. So the best practice is use clear storage structure and more responsibility per storage variables. And as we go on, I will show you more vulnerabilities that link to this as well. Okay. So here's another code. And I want us to look at this critically and look at what is wrong with this code, but especially this function, set owner. There's an issue with it. Please, I want this to be interactive. Just say something. Look at this code base the way it is now. So this is a contract that this is just a snippet copied from it. All right, go ahead. Thank you.
So instead of passing a contract address variable or new owner, you can just get the caller of the person that is calling the function by get caller address and pass it there instead.
You are very close, but that's not the issue here. You are very, very close, but that's not the issue here. It's like you're already telling me the solutions to it, but you're not telling me the issue.
Okay,
Is
the
anybody else? Okay, go ahead.
maybe let me just. I think the issue is uh, there is an unused import.
Okay.
And and John Bosco is raising his hand.
All right, go ahead, John Bosco. If you have something to say, yeah.
Never mind, never mind. I think you've said what I want to say.
Okay, so I mean, you guys are really close, but that's not the issue. Just as a set owner function, it is a critical function where you are setting the owner of this contract, right? But there's an issue here. Anybody can call this set owner function and become the owner of this contract. Did you see that? There is no check that who is calling this function must be the previous owner or must be the owner that must be that been set maybe on the in the while deploying this contract in the constructor. But yeah, it wasn't specific. So when you said this owner here, anybody can call. There's no check to know who is the previous owner. Is it the previous owner that is calling this set owner function or another person? And just as the other person said about getting the caller address, you're supposed to get the caller address compared to what we have here in this owner before you now write to the state. And this is the correct code snippet here, right? So I get the caller address, whoever is calling the set owner function. I compare it to what we have in our storage here, the owner. And if this caller is not the same person we have here, you are not authorized to set this function. But if you are the caller, then you cannot set another new owner. So let's say we have a functions that maybe you have a withdraw, people can withdraw from, or an admin functions that maybe sets, maybe you are doing a whitelisted contract whereby people need to be whitelisted before they can do something, and you have the admin that need to set them to true, right? And this is the functions to set owner. Maybe during deployment, you already have an owner, then you want to transfer ownership to another user. But this function is not protected. So I can just come to this code base and say, oh, I can even become this owner of this contract. Then I come here, set owner, I set it to myself. Nothing is stopping me. Then I can do every other admin operation on this code base without being restricted because I'm not the new owner. But if this uh checks was implemented in this code base right here, it's to prevent any other person to call this function except the caller, except the owner that owns this contract or whoever has the owner role to call this function. So uh, these are little things that maybe when you write code, you kind of miss you because you are trying to just make this thing works, right? You kind of miss this part. Oh, I'm supposed to have this. I'm supposed to implement this, right? Okay, so let's move to another one here. This is a bit complicated, but yeah, we can do it. So, so what do you think is wrong with this? So let me just I tell you what this contract does. A code snippet from a contract that I copied and show. So is a this contract um is a bridge contract that handles transfer of asset from L1 to L2, right? So you can have like your asset on L2, you want to transfer to L1 to another contract on L1. This undo the deposit, right? So this is what this contract does. And then we have the LWA governor, we have the balances. This tracks the balance of users, control address 256. And then we have this is the annual deposit functions. It takes in the from address, the user, the user is calling it, and the amount that's been passing here. And then it's reading the balance before updating the balance here. Just the way I proposed earlier that you should always read balance before you now add to it. This is what it's doing here. But there's an issue with this contract. Anybody wants to give it a try? John Bosco.
Is it that?
Sir, just give us a minute. Let's just go.
All right, go through it.
Sorry, can you hear me?
I can hear you.
I've been going through it, and I think the issue is in the handle deposit function.
All right.
The it's writing to it's updating the balance, but I don't. There's no transaction going on.
Mm, that's not it. That's not it. That's not the issue.
Sir, could it be that there should be like a snapshot in the
Mm.
L1 handler?
So the way the L1 handler works is an there is if you've gone through the way Cairo processes cross-chain messaging, they have like a template or a boilerplate that they use for it, and they have like a so the way chain messaging works is you have like a node that runs that picks up events that is emitted maybe from the layer two chains or the layer one chains, and then process it and then calls the other functions on. Let's say you are trying to send a message from L1 to L2 now. When you make the function call on L1, it emits an event, the node picks it up or the engine picks it up and makes the contract call on the L2 chains. So this handle deposit now, this is the L1 handler now. So you send it from the L2, it emits an event, the L1 handler picks it up and then call the functions handle deposit here on the L1 handler to update the state that okay, this is the current balance of this particular user. But there's an issue with this function. And because this is something related to visibility of this handle deposit, we expect the node or the node is running or the engine is running to make this call, this on the deposit call, right? But there is a missing check here that this contract is missing.
So,
Um,
sir, it's not the snapshot in the web itself
Mhm.
that's the problem.
Yeah,
is it an assertion problem? Like,
yeah, it's an assertion problem
so
because
it's
this deposit. Okay, go ahead.
sorry.
Go
Okay, it's
ahead.
not certain that the person that should carry out the transaction should be the L1 governor.
Exactly, exactly. This handle deposit is meant to update the state here. So that means I can just come to this handle deposit, pass in any amount here, and then I'll update my balance because this is meant to be called by the L1 governor on the L1 chain. So when you send a message from the L2, emits an event, and the node picks it up and send a message, the L1 handler, which is this L1 governor, is meant to call this function and then update the balance. But if this function is not protected, anybody can come and call handle deposit an L1 handler and then pass in any amount and then that's it. In fact, there was one contest I participated in that had these similar issues, but not necessarily like these or check about who is calling it. It's about the amount being sent. So the way they do it is user stake on the L2, right? And then they emit an event to monitor the stakes on L1 chain. So we stake 200 USDC, it emits an event, the L1 picks it up and updates the state. Okay, this user has staked this also amount on the L1 chain. So that when the reward is being shared or when they can know how much should be allocated to that user. But there's an issue with that code base, right? When users wants to withdraw, you can withdraw on the L2 chains, right? Maybe I have 2,000 as my wallet balance, total deposit I've made in the code in the contract, and I withdraw 500, right? My balance should be 1.5. On the L2 chains, it works that way. It manages the balance where it updates the state to 1.5, and then it emits an event that release 500 to this user on the L1 chain. But the problem with it is when it goes to the L1 chain, the L1 chain did not check what amount is meant to be sent to the user. What it does for it just check the total balance of that user, total amount the user have staked and send it to the user. So on the L2 chain, I still have 1.5 as my balance. and then on the L1 chain, the total amount that I've saved so far, 2,000, has been sent to to me. So I can come again, go to L1 chain, withdraw another 500. The L1 chain will still see it. Oh, 2,000 deposit, 2,000 should be withdrawn and sent to be this user. Till, and I can use that method to drain the contract. So this is something similar to that as well here. But the issue is with the check here. The L1 governor check. They're not checking who is calling this under deposit function. All right. And we can see that now sorry, we'll go back a bit. You can see now we are verifying the source of the message. We are checking that whoever is calling this function is the L1 governor. It's our trusted L1 governor that can only call this under deposit, not any user. So we have verified the source of this because it's an open functions, right? We must verify where the source is coming from because we have the contract deployed on L1 to undo any calls that are making from our L2 chains. So we must be able to verify who is calling this our undo deposit function. So nobody's calling and changing the state of the chain for us. And that's why you have this check here. We check that it's our trusted L1 bridge that's making that call. Else is going to revert that invalid L1 sender. And then it just reads the user balance, then add to it. Okay, so the issue here is access control issues, right? We are missing the caller validation, and we are using get caller address incorrectly. Although we have it in our input, but we are not using it in some of the function. So what some of the attack we can notice with that is unauthorized mint, unauthorized upgrade, fund can be drained, just as we have it here now. So you can increase your deposit and they can go ahead and withdraw any amount from the contract. As long as the contract has that balance, you can always just go ahead and withdraw. So you must explicitly declare your admin rules and you must explicitly check whoever is calling. We don't have modifiers in Cairo, unlike Solidity that you can have a modifier. But yes, you can still have a check, just the way we have it here, right? To check whoever is calling the function to be sure that it's the right user that is calling it, it's the right admin that is calling the function. Okay, here is another code, and this issue is related to fetch data type. So let me just briefly talk about fetch data types. By default, unit data types, they have overflow and underflow protection in the sense that, let's say I declare a value as unit 8. That means that container can contain only 8 values. If I add other values to it, let's say I add 2 more values to it, it's going to overflow, and then it changes to 2. So I can take in 8 datas or 8 values, and I already have 7 values in me. That means I can only take one more value to fill in my box. And then a user is now sending 2 values to me, trying to add 2 values to the already existed 7 values. That's going to make 9, and that's bigger than what I can contain. It's going to overflow. Then the container will only have a value inside of it. That's the issue with integer. And integer overflow, underflow. Underflow is the other way around. But with Starknet and Cairo, they have that protection. You can't experience overflow, underflow of it. It's going to revert if you are doing any operation that's going to lead to overflow or underflow. But with 3252 operation, you don't have that protection of overflow, underflow protection, which means if you have a value that is greater than the 3252 balance, or the value that 3252 can hold, is possibility of you having overflow and possibility of you underflow with that data. So this is a process point system. I want you guys to tell me what you think is wrong with this. Peter, you want to give it a try?
I think the problem is coming from the variable let current equal to self. Okay, okay, no.
So this point system is tracking user points. Let's say it's a game now, and they're giving user points based on maybe your current stage, right? And this is storing the user point of mapping of user address to 3252. That's not the user point. And this is the process point that is adding the point. Forget the fact that we don't have maybe access control. Maybe we're supposed to call this process point, right? But that's not the bone of contention here. We just want to look at what can happen to this user point here. Let me just show a demo of something here. Let me see if I can minute. Oops. Oh, sorry. I need to unshare and share back, please. A minute. So, yeah. All right. Okay. Can you see my screen?
Yes, yes, that's it.
Right. Okay. So here's a 252 operation. I want to demonstrate what I mean by overflow to you guys. So this is the
Can
maximum.
you zoom in?
All right. Okay. Okay. Let me activate my error. Okay. So this is the maximum value that 3252 can have. 3252 data type. This is the maximum value that it can have. So I know this is a stretch, right? This is a stretch. It's very hard for user to have the total point. I'm trying to explain what can happen to that point system. So this is this is the total value that F852 can hold, and I just minus one here, and we have 80 here. So if I try to add two to it, it's going to overflow, and I will demonstrate that to you guys now. Okay, scar basic here. All right, on the flow example, right? Okay, good. You can see that on the floor. Oh, I want to try this out, not on the floor. Sorry. Yeah. You can see that result of overflow is 1. So this is how I went from having this total point to having 1 point. Do you get the issue here? So I have this point already, and then I'm trying to add 2 more points to it. But unfortunately, this is a 252. It cannot hold more than this large data of 81. So it's going to overflow, and it's going to set the next number after it, which is 1. So let's say I'm trying to add 3 to it now. It's going to minus 1, then I have 2 as my total point. So that's the issue with 3252. If you look at this U8 now, unit 8, right? The maximum number that unit 8 can store is 255. So if I try to do an operation that will increase it more than this 255 balance, we are going to get a panic error. A compiler is going to panic. Let's see. You can see now that it's panic with U8 add overflow. There's an overflow error. So if you're using uint to undo your operation, you are protected by the overflow and underflow protection. But if you're using FET252 to undo your arithmetic compression, there's possibility of you experiencing overflow, underflow. So let me demonstrate the underflow to you as well. So this is the underflow example. Okay, so this is the point that user have 5, and we're trying to reduce the user point. So let's say we discover that this user was cheating, right? And we want to reduce the point. We are giving a slide. We are slashing the user point by 10. if you try to do this subtraction of the user's point minus 10, you discover that we know that this is going to give us a negative number, right? So if we do that, we're going to have an underflow. Can you see? This is not the user point. Instead of user to have a negative 5, right? It's not having this total point. But it's supposed to be an arithmetic operation, right? A unit operation. Now we're going to have a panic or a revert error that cannot perform that operation because it's going to lead to an underflow. But because we are using Fed 252, we don't have that protection, and that is why when you do this 5 minus 10, it leads to another flow. So going back to this our guy here. Wait, are you guys seeing my screen?
Not right now.
Oh, okay. All right. I don't know why. But you're able to see the demo I did with the code snippet I showed, right? The underflow and overflow.
Yes.
All right. So let me show. Okay, a minute. So looking at this our point system now, we discovered that there's possibility that we have an overflow here. Because when it gets to a point, let's say miraculously or based on the point calculation, users are maybe luckily for them are able to have like a point so close to the total maximum value that 5252 can take, and then you try to add to it can lead to have overflowing, and then user points will get reduced. So the proper check to do is use integer to handle anything related to arithmetic operation. If it's possible, just use integer to handle all arithmetic operations. And we can say that this is U256, right? And then we read the user point, and then we try to do an addition. If it's going to overflow, we're going to get a panic error from our compiler that an overflow can occur here. So it doesn't need to change what's it called, the user's point from being a positive to a negative value, right? Or you can just do a manual start to check if this value is going to overflow, just revert or do any other operations. Okay, so let's do another one. All right. This is this is also this is keeping track of users balance, right? Mapping of control address to 5252, and you have a withdraw function here. It takes in gets the caller address, who is calling this thing, check the caller's balance, and then withdraw this amount. But there's an issue here. If the amount you are trying to withdraw is greater than your balance, this is not going to revert. It's going to overflow. Just where I demonstrated earlier when I was doing the overflow, when I was doing 5 minus 10, that is underflow. Same thing is going to happen here. If you are trying to withdraw more than the amount that you have in your balance here, this is not going to revert. It's just going to increase, and then you have your balance being increased here. And then if you try to do a transfer, it's still going to transfer the amount out. So instead of you to have a reduction in the amount you have in your balance, it's getting increased. And this is the solution to that. You can check, you can assert that the amount that you're trying to withdraw is less than or equal to your balance. If it is less, if it's not less than your balance, it should revert with sufficient balance, right? Do you guys understand me? Okay, go ahead.
Okay. So yes, I understand what you've done so far, but I have a question. So we know that belt 252 is a short, can also be referred to as a short string, and using felt 252 for calculating balance is not recommended. But
Yeah.
you can use felt 252 to like take a string input, or let's say you want somebody to like give his name. You don't expect the person's name to be longer than, I think a short string is not longer than 32 bytes or something. You don't expect it to be
Mhm.
longer than that. But I also know that byte array can also be used for strings. So in what cases should we use fields 252, and in what cases should we use byte array? That, that's my question.
Hi.
That. So sorry. A minute. Okay, sorry about that.
Um,
Okay, so you were asking a question the other time, right?
yeah, I was asking in what cases and what situations do we use field 252 and um, byte array when
So
handling string, like when you want to like collect an input, let's say somebody's name or something like that.
so I think the thing is when you are doing anything related to an arithmetic operation, you should avoid using 3252. You can use 3252 for other things. When it comes to arithmetic operation, you should avoid using 3252. Use the right data type for it, which is uint value. It can be uint 8, uint 256, uint 16. Because you only have these operational these issues when you're trying to do additions or subtraction, right? Or you're trying to do an arithmetic operation on 3252. So it's better when you want to do anything related to arithmetic operation, avoid using 3252. Use the uint equivalent of it, which works well. Because another thing with 3252 is if you compare, if 3252 can only hold 252 bits of data, uint 256 can hold 256 bits of data. If you're trying to bring data from a container of U256 and you want to like bring it to 252, it cannot hold I'm just using container to just explain it better, right? So it cannot hold the value of U256, which this can lead to other problem as well. Let's say you're trying to do a I'm looking at a reason why you need to bring data from a 256 to 252, right? But let's just say you are working with something that requires now, okay, transfer your data from a U256 to 5252. You are going to, because this container cannot hold that data, you are going to have an issue with that as well. So anytime you want to do data operations that requires unit values or numbers, just use uint 256 for it, or use the unit equivalent for it, not 3252, because arithmetic operations with 3252s are not protected by underflow and overflow. All right. So yeah, we just check that. So this is the fix to this. You check that the amount that you are trying to withdraw is less than or equals to balance, right? Before you can make this withdrawal. Okay. So this is another uh issue, another vulnerability related to bridge, which is deposit to L2. So I guess I'm trying to remember where I got this snippet from. All right. Okay. I think this is this is a staking contract. So yeah, that's like a contract that handles staking for users. This is on behalf of the user, and this is two, and this is the amount. So because of address differences between L1 and L2, you have to convert your address to UNT56, right, and pass it as on behalf and UNT56 to and then to amount, and then it emits the event, emit deposited on behalf to amount, and then you have the L2 receiver now, right? This is Starknet now, receiving this data from L1, this on behalf 5252, recipient 5252. So let's just keep the amount for now. We are not dealing with the amount here. And they do, and we have save balances the right recipient amount. So what it does is we undo your deposit to L2 for you. So this is who is making the deposit. This is where you are making the deposit to. I don't want to show that here. This is who you are making the deposit to, and this is the amount you are trying to deposit. So you've deposited, we've collected the token to you, we transfer it on your behalf here, and we emit the deposit on behalf to amount. So, and then we have the receiver, our to receiver, that handles your deposit, transfer wherever you want to transfer into. Then it takes the recipient, right? 5252. This is a Starknet address. This is an Ethereum address because on behalf, this is on L1 now. You're on L1. That's Ethereum. You're trying to make that call. So this on behalf is an Ethereum address. This too is a Starknet address because you're making a deposit to an address on Starknet on the layer two. So this is the layer two now. Is receiving the on behalf now 5252 and the recipient as 5252. Save balances the right recipient and 100. So for the recipient, you're making the call to saving it as 100, and then sets the card dot right on behalf. So who is making this stake or who is making this deposit, and this is the amount user is deposit. But there's an issue here, and there's an issue here. And the so this is kind of complex, so I'll probably just explain this. And the issue is with the way addresses are being handled by both L1 and L2, right? So because this is a Unit 256, right? When you call this functional, there is no check to verify that this is a valid, because you are passing the address as a Unit 256, right? Not as address the way we have it on L1. That's solidity now, because Cairo does not understand address. It does not understand the address data type. That's why this needs to be converted to Unit 256, and then to now we have it as 5252 here. But address is 160 bit. Address on Ethereum is 160 bit. That's 20 bytes. 2x make it 2x, right? Yeah, I'm right. 160. That's 160 bit. So it is still less than 252 bit here. So it's gonna work. But we don't know this interface on behalf. We don't know if it's the valid address that is being passed in here. Probably maybe when we're doing the conversions, there's a mistake or something that is being done when they pass it here. And then it comes here. The receipt from L1 does not make a check on, oh, this particular data that I received, is it a valid Ethereum address before I go ahead and do a stake right here. So this is the check here now. So we are taking the deposit too. So the first thing that I proposed here while I was looking at this code snippet is receive the passing the address on behalf and do the conversion inside the contract, because we don't trust users with input. When you say, oh, users are going to do this like this, users can do things you did not expect, did not factor in when writing your code. You expect users to input, oh, this user cannot do more than 2 plus 2 now. Then you start seeing users doing 1 million plus 1 million, 1,000 plus 1,000. And that's one thing with building applications. You don't expect users to think this way. Users can do things out of what you did not plan for. So this is the plan here. The plan is take the address of whoever you are making deposit to and do the conversion in here. So you are sure that the address that is being passed in here is a proper address on Ethereum, because this is a Solidity code base now. This is on Ethereum, right? This is Solidity code base. So we are doing the proper conversion to Unity 56, and then we are emitting the deposit. If you've gone to the Cairo book, I'm seeing the way they handles the L1 to L2 operation. You realize that when you're making the call to the L1, L2 operations, it takes in the address as 0256. In as much as address is 160 bit, we could have used int 160, but because it takes as int 256, we have to do conversion from int 160 to int 256, and then emit the deposit here. Then this is where we are not doing the check here. Let me bring this to this side. We are doing the check here because we know the Ethereum address is 160 bit. We know that the total max of L1 address is this. So when we get here, when the receive from L1 picks this, receives the function call, it checks that this on behalf they are passing in is less than or equals to max L1 address. It's checking that this address you are passing in, I want to be sure that it is an Ethereum address using the amount of the value, using the value as a parameter to do the check. If not, it's going to revert with an invalid L1 address. Although with this check that we did here, we already saved because we are doing the conversion ourselves before we do the deposit. But let's say there is no check here, and then you still try to like make the call here. This in some way will be able to help you to minimize maybe depositing or to a wrong address or getting another address. Because if let's say you pass in another invalid address or something, this conversion will work and this on behalf will be another address entirely. This is different from whatever the user passing as deposit to L2 here. So that's why you have this critical validation that checks, oh, this on behalf, this address you're passing it, is it a valid L1 address? If not, it's going to revert to an invalid L1 address. And then you can then emit an event and then you can undo that maybe off chain or something. So that is so this issue is related with 252 operation, Unit operations, and cross-chain operations. So you might be working with an application that requires you to do like an L1 to L2 operations, and you want to be able to undo different addresses across different chains. These are like mini checks that you can do to undo that operation. All right. Um, So just the way I said, 3252 is not bonded like Uint. Overflow don't revert automatically when you are working with 3252 and also with underflow as well. And some of the common issues we have with arithmetic assumption and comparing FET incorrectly. When you're trying to compare FET to into 56, there could be mistake with where you are handling that. So you must always have an explicit range checks and use integers where possible, just where I said earlier. When you are doing working with anything arithmetic operation, it's best advised that you use integers to handle your operations and not FET for your arithmetic operation. Okay, are we clear? Let me just see your thumbs up or something to know if you're still following me. All right, thank you. Okay, so here is another contract. Okay, so I think this is related to reentrancy. This is the intention. So basically, what the entrance is, you find the entrance more in Solidity. Sorry, I'm referring to Solidity here because most of the time, because Solidity is the layer one change that Ethereum is built, that Starknet is built on. So there will still be a bit of contract cost between L1 and L2 like that. So reentrancy is when you make an external call to another contract and then it can call back to the functions. So in Solidity now, let's say you do a native token transfer, ETH transfer, you can have a contract as your receiver, and that's a fallback or receive function. So when you have fallback or receive function, you can specify what happens when you receive a token. So when you receive it, you can determine what you want your contract, how you want your contract to react to that deposit. So with that, you can make a callback to your withdraw function and do some other things again. If you don't have explicit protection, this can lead to draining of the contract. So, but this is not possible on Starknet. But there are other types of reentrancy that can happen on Starknet. Because when you read articles about Starknet, you see, oh, they tell you no reentrancy on Starknet, no reentrancy, you cannot have reentrancy on Cairo. But there are ways that reentrancy can occur, and this is like an example of how it can occur. And I want you to look at this. So this is the vault contract, and this is the lender. So this is the vault that handles your deposit and everything, and this is where this is the lending where you lend your asset out, or you lend your asset and then you receive an ROI or something. Yeah, this way it just does. So I want you to like look at, I know this can be a bit hard, but the issue here is something that I feel we can figure out just looking at it. All right, go ahead, Peter.
Okay, so the issue is it with the vault contract?
Okay.
Okay, there you are. The transaction is happening before you're updating the balance.
Yes, you are right. You're right. So there's something called check effect interactions. You do your check, you do the effect before interaction. When we look at this contract, there's a check here that okay, oh sorry about that. There's a check that oh the balance is greater than or equals to the amount you are trying to withdraw, which is fine. Yeah. So we are sure that oh you're not withdrawing more than your balance. This check is fine. Then they're making a call to our lender to let them down know, oh, lender, so user has withdraw this also amount to. let's just check if this user can be liquidated or not. So let's say you have or you've saved 1,000 now, and you want to you have 1,000 as your collateral, and you've probably borrowed an asset that's worth 600 or something, and then your collateral margin is almost close to liquidation, right? So this notify withdrawal needs to check. Oh, before these users can withdraw this thing, is this person safe from liquidation, or we can just go ahead and liquidate this user? This is what this lender. This is why this withdrawal is making a call to lender to let lender knows. Oh, this user has done a withdrawal. Please check, is this transaction safe? Should we go ahead and disperse this money to the user or not? But one mistake here is they are making this uh this update here after they've made these interactions. And if you look at this lender notify withdrawal functions, it's taking the user control as amount and it's checking the user balance. But at this point, when you are making this call here, user balance is still 1,000. So I'll probably do a proper snippet walkthrough of this. So the user balance is still 1,000. This is what we are getting here. Whereas you are making a withdrawal of 200 already. This should have been updated to 800. So that by the time you are checking the balance here, this lender needs to know the balance is now 800. And then check, so is this collateral okay? Can I go ahead and do it? But no, it does not. The interaction, this contract call was done before this balance update. So this save dot balance should have been done here. So you're updating the balance to maybe 800 here, and then making a call to lender to notify lender. This is so that is happening. Should we liquidate the users or not? So I will show. I think I have a breakthrough here. All right. Okay. So this is like a breakdown of what is happening there. Let's say the vote balance is 100 token, and in lender contract now you've borrowed 600 tokens, right? And the collateral ratio is 150%. So this is like a DeFi application, right? The collateral ratio is 150%. So you are required to have 900 tokens for whatever. So in your vote balance, you're supposed to have 900 tokens to be safe from liquidation. So you have 1,000, which means you are still safe, which is fine. But now you come to the contract to the vote to withdraw 200. It checks the balance here. This check here, this asset balance greater than amount. That's what we are seeing here. It checks that the balance, which is one, is greater than 2. This is fine. Then it notifies the lender functions to notify withdrawal of user 200. The lender calls back. This is where the interest is coming in now. This is a redirection actually. It's making a call to our vote to get the balance of that user, and it does 1,000. This is where the issue is. At this point, this balance should be 800, so we can know that, oh, this amount you're trying to withdraw is not able to cover your collateral because you're supposed to have 900 collateral. So that means you're only eligible to withdraw 100, not 200. But because the state update was done after this external call was made. So the balance is still 1,000, not yet updated. And then later checks, oh, 1,000 is greater than the 900 required. Yeah, you're supposed to have 900 and the balance is still 1,000. User appears safe and later does not liquidate. Then finally now transfers the 200 and now user now has 800. So user has now 800 collateral for 800. That means user is under collateralized. So I don't know, do you get what is happening here or you want me to go over it again? I know this is a bit complex, more of a DeFi application. All right, I can see Peter reacting. Do you guys want me to go over it again or you're fine with it? Okay, so this is the proper way to get this done here. So this is the withdraw function, right? We check the user asset of balance, which is fine. Then the effect, update the state first before you make any external call. So anytime you're working with then we are working with when you're writing your code, you should always have this at the back of your mind that do your check first, effect, that is update state first before you make any external call. The same thing with withdrawal with any of the contract calls you're making. Do all the state updates before making external calls. So with this now, you are sure that the balance has been updated already here. So by the time you are making call to notify lender to let them down knows, oh, this has withdrawn 200, you already knows that your balance is now 800 and is not 1,000 anymore. You see here. So by the times if we've done the update here, yeah, this update balance before we make this call. This line 7 was done at before line 3, right? This line 4 will be showing 800, not 1000 anymore. So that's a reintrance example. Okay. Okay, so this is an example of a logic and state inconsistency, incorrect order of state updates. So what you're supposed to do before making external call, you're not doing it, and you're doing an external call before making your update. And so missing check before state changes, broken invariant. So these are the problems that we experience with this. So example is updating balance before validation, and then partial update on failure. So the best practice is do your check if interaction, CE high, do check, update the state, and then make external call. Okay, so this I'm done with code reviews and everything. So now we're just under security, secure Cairo best practice. So always validate input strictly. So anytime you're taking parameters from user, because users can be cunning with their input, you need to always validate users' input strictly. Always keep functions small and explicit as well. When you are working with functions, you don't have to put all the logic inside of one function. It's okay if you break it down to different functions, to small functions, so you can easily know what is happening. Let's say you are trying to work on a calculator now. You don't have to put all the whole logic of addition, subtraction, multiplication inside just one function call. You can break it down to have something that handles addition, wants to handle multiplications, wants to handle subtraction. So if there's any issue, you can easily track where the issue is coming from. You can easily know where it is failing. All right. Another thing is fail fast. So always start very early instead of doing. Maybe you are trying to do a withdrawal now. Before you do anything, check that user have enough balance for that withdrawal is trying to make. There's no point doing external calls, doing all these things before when maybe after doing all the whole calls finish at the maybe last line of your code, you're not checking if the balance if user have enough balance. It leads to so the best thing is start early so you can know what is happening. You can know user maybe this user is eligible to do this or not. Maybe it's an admin function that requires an admin to make that call. Before anything should happen inside that function call, check that it is the admin that is making that contract call, not after the whole logic has been done, after the whole operation has been done. It's when you are not making the check that it is admin that is making that call. So fail fast. And then avoid unnecessary complexity. If it is addition, let your addition be addition. There's no point doing modulo, doing operations that is unnecessary, right? So just make it simple. Some people tries to feel to build things because I'm an OG, I can write complex code base. They may try to make things complex, but making it easy to read is the best thing. So avoid unnecessary complexity. Also document assumptions. What I mean by document assumption here is if you know okay that maybe anytime users makes a withdrawal, you want to charge a fee of maybe 5%. Your assumption is, oh, there should be 5% deduction on this deposit on this withdrawal. So you should always check for that. Maybe when writing your test in your code, and okay, yeah, this 5% is deducted. So it's part of your document. You have it written down. So by the time you are done with writing your whole contract, you can always go to your assumptions that you've documented down. Okay, these are things at least that are supposed to code when you do this function. So maybe when you stake, you're supposed to get a token in return, and you're supposed to get an NFT minted to you. You're supposed to get these things back when you stake. So that means that's the assumption for that particular function. So maybe when you're not done writing your code or when you're writing your contract, you can then go ahead. Okay, does this assumption pass? Do I have all these checks ticked when user do this operation? When user perform this operation, that's what it means by documenting assumption. Also test edge cases as well. So edge cases is like, oh, things that you don't think is gonna be feasible, right? But you just know, let me just test this edge case. This thing can be it's not something that happens normally, but it's something that can happen. I think that's just the basic explanation of that. It's not something that happens normally, but it's something that can happen. So you have to test for edge cases in your code base. Like okay, so this is solidity code base, right? It's a function that allows user to deposit a native token and ARC20, right? But in the contract, they are checking if you are depositing with ARC20 or if you're depositing with native token. But there's no check for if users is depositing with ERC20 and native token at the same time, which is possible. And these are edge cases, but as a developer, you know that why will you want to deposit both ERC20 and native token at the same time? You're supposed to deposit either ERC20 token or native token. So that's from the developer perspective, right? This is what you're supposed to do. But users can be corny in their way, and attackers also can also be corny because they are not coming to work the way you are expected them to work. They are coming in the way they feel that they want to work. They want to break your system. So what will happen if I deposit ETH and native token at the same time? What will happen to this function? What state update will happen? Will I lose my fund? Will I get more than what I have? So this is what it means by testing edge cases in your function call. All right. Another thing is unit test is not equal security. So and I think your next class will be on testing. Maybe you write tests to test your functions, right? To test your contract out. But that does not mean your contract is secure because you wrote unit tests to test some things that does not mean your contract is secured. Even codes that get audited still get exploited. So unit test is not a certificate that to tell you, oh, I'm done. My contract is secure. All right, so for first where possible, there's something called first whereby you test your function with different parameters, like multiple parameters at the same time. Try to break it. That's where this what first means. So you can if first where possible. Code reviews matter as well. So code reviews is when you're done writing your contract, you go through each line one after the other again to know, okay, does this thing work the way I wanted it to work? Is this thing doing what I expected to do? Am I using this variable or is this the right variable I'm using? Am I making the right call to the right storage? I hope I'm not using contract balance to update user balance because there are cases like that whereby you mixed storage variables. Maybe you have a variable that is storing the total contract balance, and you have a variable that is storing user balance. Maybe when users now make a deposit and you want to update users balance, instead of you to read the user balance, you're now reading the contract balance to update the user's balance, which is bad, which is a big bug, which means user is going to have more than he or she deposited. Learn from past exploits. This is like you reading audit report of other code base. So there's something called audit report. So when you're done writing your contract, you can take your code base to audit firm or to a public contest. They will audit your code base and give you a report. So this report are always publicly available, right? You can go and read on all these publicly available report and use it to check on your own control. Okay, this also operation leads to a bug in this code base. Do I have this kind of operation in my own system as well? So you learn from past exploit. Also, we see, if you use Twitter regularly, we see a lot of update about exploit happening here and there. You can look at those of the update to learn from those updates. And also, always assume users makes mistake. Exactly, users can be funny in the way they interact with a contract or with any applications, if not necessarily contract. They press button. User will be looking for like user will not press the press another button. So always as users can make mistakes. So when you're writing your contract, you always know the user can make mistakes. You are trying to protect user from making that mistakes. Let's say you have a function that you're supposed to pay a fee to mint an NFT now, right? And you're supposed to pay maybe 50 stack token or 50 USDC for that. Users can pass in 100 USDC. But if you don't check for that mistakes now, you accept the 100 USDC and still mean the NFT to the user. But you can check. I hope this amount the user is passing in is not greater than the required fee to pay. So if it is greater than the required fee to pay, you can receive it and then refund the user back, or you can revert the transaction. But if you are assuming, oh, user should know that he or she's paying 50 now, so why should I check for that 100? User can come and put on. They can even put 1,000 because they want to mint the NFT and they are overpaying for what they are supposed to pay for 50. So always assume user can make mistakes. Every public function is an attack surface. Yeah, this is true because it's not protected. Anybody can call it public functions. You should always know that every public function is a way for attacker to attack your contract. So it must be explicitly checked. If it's a private or a protected function, and you already know, oh, it's only admin that can call this function. So you know that the attack surface is limited there. It is only admin that can cause this thing to fail. And if the admin is trusted, then you know this contract is trusted. But public functions that anybody can call, sorry, you cannot trust anybody. You cannot trust user. You cannot trust anybody using your platform. So you must explicitly check your public functions and check that everything works well. And security is continuous, not one time. And this is it. if you use Twitter very well, you see every time they post, oh, this contract was audited, this protocol was hacked today, and everything like that. Security is continuous because you've done an audit, or you've checked your code, and you feel everything is working fine. Does not mean it is working fine. You must always continuously check, because every time there is a new attack pattern, every day people are innovative, people are doing performing operations, they are becoming innovative with their attack path. So what did not work yesterday might be the next thing that will be working today. So you must always put that back in your mind that security is continuous and it's not a one-time thing. Because you have done a public audit or you have done a private audit, you think that's it. No. If you go to Cantina or Immunify, they have their bug bounty platform whereby big protocols that have been audited before are still on this bug bounty platform that people can come and check. If you can find a bug, they reward you for that. So let's put at the back of my mind that security is continuous not one time. And always assume that attackers are smarter. This is it. Attackers are always smarter than we developers. So when writing your code or when building your protocol, you should always assume that attackers are smarter. So always try to minimize uh your exploit. If there's a way to get things reduced, maybe your contract being maybe you're going to make your contract modular in the sense that if this particular contract is hacked, this other part does not get affected, right? Maybe instead of having one pool to hold all the funds, you can break the funds into different pools, which means if this pool got hacked, it does not affect other pools. So those are other ways like make your to reduce the exploit performed on your contract. So let's assume that attackers are smarter. Okay. So this section 5, I think we're almost done. Uh, Getting your project audited. So please react if you are still following me. I want to know if you guys are still following me. Let me see thumbs up, please. All right. Thank you, Peter. Why audit matters? So when you do audit, it catch critical variability early, because when you do audit, you are not the one reviewing it now. It's another entity, other platform, other users, or other auditors are reviewing your contract for you. So you've written your own code base, you've done everything from your whole hand, and you feel like, oh, this thing works fine now, it's working well. Now you take it to an audit firm. They'll now look at it from their own angle, look at how they can break your protocol. And with that, they can catch vulnerability early and they can tell you, oh, this operation that you performed there is not right, to can lead to this exploit. So you can fix it. This is the main reason why audit matters. You see all these breakage protocols, they do audits. The Starknet taking contracts that I think that was probably last year something. It went through an audit as well. And people find critical vulnerability there. This is code base written by Starknet core engineers themselves. And people still found vulnerability there. So critical. So when you do audit, it opens your code base to different eyes to look at it, and they can tell you if an operation you're performing is right or not, and they can catch critical vulnerability very early, and they can tell you, oh, this operation is bad. This operation can lead to this. What are you trying to do here? This is not the right way to implement this, and stuff like that. So they can propose solutions to you, and you can just implement that. And it protects user phones and protocol reputations, right? Because we've seen protocols that close down because of an attack. Maybe after an attack, the total funds the protocol was doing. There's nothing the protocol is doing anymore. There's nothing the protocol wants to do because there's no funds. User funds are lost and protocol reputation is damaged. And you cannot revert that back again. The money is gone. If you see protocols begging hackers, please refund our money. We are going to give you 10% of the amount you stole from our contract. We're going to give you 20%. But still the end, most of that you don't get the money back, right? So to protect user funds and to protect protocol reputations, always do audit. When you are done with your writing your code base, move it from your end, move it to an audit firm, and tell them, oh, this is our protocol, this is what we do and do and do. We need an audit. We want you to audit this protocol for us. And then they will look and tell you, this is right, this is wrong, this is right, this is wrong. So to protect user funds and protocol reputation, audit really matters. And it's required for serious mainnet deployment. True. If users are going to take your protocol seriously, if they really want users to trust your protocol, you must have done an audit. You can't expect me to go and use a platform that the protocol is not audited or that the code base is not audited, which and anything can happen. Even the one that are audited get hacked as well. So not to now talk of the product that is not audited in any way. So to gain users trust and for mainnet deployment is required for your protocol to be audited. because this is what you use to convince users to use your protocol. Well, we have been audited by social firm, you have been audited by social firm, and the issue that was found have been fixed. Now it is safe to use. This is how you gain user trust. So types of smart contract audit, right? So we have the private audit and we have the public audit. So private audit is the one performed by a security firm, and this is done internally. Is it private? Is it like it's just an audit that is done privately? It's not open to general public. You go to an audit firm, maybe Sherlock, Cantina, Gid Audit. You will tell them, "Oh, I want to audit my protocol," and then they give you a timeline and cost that is going to take for the protocol to get audited. And then when they are done, they give you a confidential report. Well, this is what I for what was found in your code base, and then you can then go ahead and implement the solution proposed by them. And after that, you can still go again when you are done. Okay, I've implemented these fixes that you propose that I should do. Can you look at it again and let me know if I implemented it right? If it's safe now, they can give another report. Okay, yeah, you've done it right. It works well now. So that's private audit. It's between you and the security firm, right? It's confidential. Then we have the public audit. This one is open to multiple security researchers, and we have audit platform like Unified Cantina as well. If we have Sherlock, we have Codocs. These are public content whereby you can see protocols listed there, waiting for looking for people to come audit their protocols. So there are people called security researchers that just jump on different code base and look for try to look at the way they can ways they can attack the contract and maybe gain unauthorized access, drain funds, or do what or cause a DOS attack, right? And then they report the issues. Then at the end of the contest, you have the whole audit report. They have judges that review them and say, okay, this is right, this is possible, this is possible, and then they give you all this feedback and then send it to you. So it depends on the firm, right? On the protocol, which one they want to go for, if they want to go for private or public audit. But most times you've seen protocols move from private first, right, before they move to public. When private has been done by top security researcher, now move it to public because public opens it to multiple security researchers, not one or two. Now you have different people. Sometimes you see protocols that have like maybe 1,000 participants, 500 participants looking at your code base actively. Unlike a private audit that you only have maybe five top researchers or 10 top researchers looking at your code base. But it's public now, it's open to multiple security researchers and they can look at your code base, look for ways to doing it. So everybody's bringing their own different attack pattern, different pattern for them to break it. So that's the difference between public and private audit. And then the issues are ranked by severity. So users submit their issues. Okay, this is a critical issue, this is high issue, this is a medium issue, this is low issue, this is informational. So you have issues ranked that way. So critical means this issue can break your system protocol. Like finally, you can have high, right? You can have medium. Maybe user can drain funds. You can gain authorized access to your code base, and you can have low and information. Maybe next time to save gas, maybe do this. It's not necessarily you have this implemented, but you can do this next time just to like maybe make your code more readable and stuff like that. So these are like audit firms that we have. We have Nethermind Security, Trail of Bit, Funds of the Lens, Cetic, Git Audit. So these are audit firms that you can take your code base to your protocol to and say, oh, we have so protocol, and this is what we are working on, and we are done. We need a security audit on our code base, and we want you to look at it. So Nethermind, Trail of Bit, Open Applying, Git Audit, they can look at your code base and okay, we take it from you. This is the source amount you are going to pay. We give you we give you the result in the next 2 weeks, in the next 3 weeks, in the next 1 month, depending on the complexity of your code base and how large your code base is. And they have your public audit platform. This is one where multiple researchers can come to your code base and find bugs there. We have Code Foreigner, we have Sherlock, we have Cantina, we have Unify. So they run public audits, right? Where you can see uh, different protocol bringing their code base for audit on their. Hello, sorry about that. NEPA, they took my light, so my inverter tripped off. All right. Okay. Sorry, can you guys hear me? Hello. All right. Okay. Did you catch me to this point? Or where did you? All right. So, question. Do you have any question for me? Any question about doing audit, public, private?
I have a question.
All right. Go ahead.
So, how does one like right now? Let me just say right now, I write Cairo smart contracts, but I've not started writing. I've not been writing Cairo smart contract for a long time. But if for someone like me now to write Cairo smart contracts, how do I get to become like an auditor? How do I become an auditor? Like to audit Cairo.
Okay. Uh, First of all, I say by writing Cairo, because you can only audit what you understand, right? And you understand by writing it, and you understand by understanding the architectural design of why this blockchain works this way. Because there are some security issues or flaws that are peculiar to different blockchains, right? The way you have interest here on Starknet on Ethereum now, and also on Starknet, right? You don't have interest here on Solana. So when you're working with different blockchains, they have their trade-offs or they have issues that are peculiar to them. So you have to understand that. So what I will say is you write Cairo to understand how Cairo works. Then you can then audit Cairo code base. I can't tell you to just start auditing Cairo code base if you don't understand what Cairo is or how to write Cairo. You get. So you write Cairo, understand how Cairo works, then you now audit Cairo. And also there are platforms whereby you can do first flight. There's something called first flight, whereby they publish buggy code, like codes that have bugs, and they tell you to audit them. And then they rank your results based on whatever submission is, right? So we have platform like that as well. Another thing you can do is you can read audit reports. So we have audit report on solodit.xyz. All these top firms, they have the catalogs of audit reports based on the context on protocols that they've audited. So they have the catalogs of their report. So you can start going through each of those audit reports that they've published to understand what they found, how they found it, so that when next time you are looking at another code base, you're able to pick it up. Oh, when I read so this thing, oh, they said this thing can lead to an attack. I need to check for it here if they have this implemented here or if it can lead to this here. Because you need to gain that knowledge. So when you did audit report, it gives you a vast knowledge about what can happen, because attackers are funny in their ways. They are very creative in their ways. So when you read all those audit reports, it opens you to their mind. You can see what they are doing, how they do it. So next time you are looking at a code base that you want to audit, you can see, oh, this when I was reading this audit report, this thing was done here. It's possible this thing can be done here as well. Do you get? So that's it.
All right. Okay. So I understand. So I have another question. Since Starknet is like a layer two on Ethereum, so if I
Mhm.
want to like be able to audit Cairo smart contract basically on the Starknet ecosystem, do I also
Mhm.
need to understand how Ethereum, that's the layer one system, do I need to understand how that works also?
Uh, well, to if you want to be very good, understanding of how this different blockchain works really matters, right? Understand the upgrades they are doing. You can see that lately now, Ethereum has been moving towards post-quantum computing, changing their Ethereum virtual machine to RISC-V architecture, all those things. So all these things open up different attack path again, different from what we have before. So if you don't understand how this thing works, there we have trusted storage update, we have other updates that they are pushing. So if you're not actively working in that ecosystem or reading on that ecosystem, it'll be hard for you to audit them. We've seen issues that arises because of transient storage implementation. And transient storage is just was just implemented in storage version 0.82 something, I've forgotten, right? So that is what introduced transient storage, and they try to introduce another set of bugs. So if you don't understand how Ethereum works, how Solidity works, you can't say because of your understanding of Cairo Starknet, you cannot automatically audit uh, audit Ethereum or Solidity. And it cut across other languages as well. There are some issues that are related to logics, right? Maybe you not check for uh, access control validation. Now that cut across different chains because you need to assert for access control validation, right? But there are some issues that are peculiar to the architecture of that chain or to the language design of that chain of that protocol. So you need to understand that to be able to say you can fully audit that. There are people that audit without basically understanding how this works. Yeah, they're able to find one or two things, but the core things they are unable to. They can't find critical core vulnerability that way. Yeah. So I hope I answer your question. All right. Any more question? Any more question? Okay. So if there are no more questions, we've come to the end of today's class. Thank you all for joining today's class. Hope you are able to enjoy my class today. I know it's a bit technical and we're able to like think of concept outside the usual thing we've been doing all this while. But yeah, I hope you enjoy this class. Thank you so much for having me. So I'll be handing over to the moderator. All right.
Yeah,
So,
thank you so much.
all right.
Thank you so much, Black
Mr.
Adam.
Mr.
Okay.
Adams, I have a question. Sorry.
All right, go ahead.
Okay, it's just quick. This auditing, what's like the difference between auditing and like the Cairo testing? Is there like a difference or they're just the same thing? Auditing is just like them.
Auditing just like the
Like you
term,
want to
right?
write the Cairo test.
Yes, yes, yes. Auditing
Okay.
like the time. You carry. You just. Hello, can you hear me?
Sorry, we didn't quite, yeah, the connection was cut off. Can you please come again?
Okay. So what I was saying is they are intertwined. The both audit and Cairo testing, right? They're both intertwined in nature. But what I'm saying is when you're writing tests, you're not writing tests to say, oh, this thing works, this thing works, this thing works. But with audit, it encompasses more than just testing alone. You are looking at other things that can affect your protocol, which is different from just the usual testing. So but auditing is like a broader term for it, while testing is just a subsidiary in audit. Yeah,
Okay, sir. Thank you.
you're welcome.
Yeah, thank you so much, Black Adam, for the amazing lecture. I would say it's amazing because you really tried to like ensure that everyone was actually in sync, to be honest, which is very cool. And
Thank you.
yeah, I'm quite happy that we almost coming to the end of the boot camp. Right? It was just 5 weeks, and that's on Thursday we would have the last lecture, which will be on testing, which John Bosco was asking what's the difference between testing and auditing. But yeah, I mean, by that class, you're able to like have deeper knowledge on what's actually differentiates both of them. On the other side, I just want to confirm if everyone has started building up their projects for the hackathon and all, because we just have like you just have okay. 20 days. Let me say approximately 20 something days, right? So if you have not yet started building or you're looking for a team, you should join the Telegram group and ask for just interact and start building it, because the most important um thing for like aspect of this bootcamp, of course, is to develop your knowledge on Cairo, learn more about Starknet and all. But it's going to be very amazing if some people from this bootcamp win some prizes from the hackathon at the end of the day, because I mean, of course, it's going to be a great addition to see that. So if you have any question regarding the hackathon, join the group and ask your questions, and also form teams and start building immediately. I would actually give this tip. I heard someone say they are building game, which is amazing. But I've actually learned from the past hackathons that they kind of like right now, if you have a look, they lean into games, and also they also lean into um Bitcoin on Starknet, right? So if you have any idea about like Bitcoin related dApps that can be built on Starknet, you can actually explore that as well. Yes, it has a lot of potential to grab some prize and in the hackathon. So, and as well, there is a list that the foundation shared that is on the Notion page, so you can have a look at it and check if any of that like resonates with you. Like I said, if you have any question, you should ask in the shared group, because every tutor is in there to assist and help you, like even solve any issue or any problem like you're encountering while you're building. But that aside, thank you all for always joining, and see you all in the last class on Thursday. And after then, we're going to have a few weeks or a few week then now do the graduation, and also please submit your assignments so we can have better grading of everyone. Thank you so much for joining, and see you on Thursday.